Hey there, in this video I'm going to show you how to use container widgets. These are widgets that hold other widgets, and by stacking container widgets within each other we can build some pretty complicated looking user interfaces in our notebook and get some really nice looking results. So I'm going to work by way of an example. I'm going to start simple and make it more complex as we go. And the code I want to make is something that interactively makes a graph. So we're going to control things like the range of values on the x-axis and the y-axis. We'll do an imshow type graph, so it's kind of pretty. We'll have some kind of drop down for different color maps. I think we'll even go so far as have it be customizable what function we actually plot. So let's start with that customized function. I'm going to need to make some kind of widget that will let me enter in Python code for the function that will then be executed in the notebook. So I'm going to call that widget fText because it's going to be a text box widget. Out of widgets, I'm going to make a new text. And let's set some of the keywords for that. We're going to make the starting value something real simple like x plus y. We'll make the description be something that's kind of meaningful, so we'll do like f of x comma y, maybe with like a nice colon after it. I think this is a case where we definitely want to turn off continuous update. We don't want it to keep trying to run Python code as it's typed in, because that is going to make it show us a bunch of bugs or like a bunch of error messages. So continuous update equals false. And let's preview what this widget looks like. So I've already imported display, just like I've already imported widgets. If I display a widget, even if it's not connected to anything, that's okay. It lets me see what it looks like. So this is like a preview of my text box, and you can see I can type in here, and at the moment it doesn't do anything because it's not connected. So let's make some more widgets and then we'll connect them all up. The next thing I want to make is a couple sliders to control the limits on the x-axis and the y-axis. I'm going to want to set both a lower and upper limit. Now, if we used individual sliders for the lower and upper limit, we could run into some trouble where, like, what happens if the upper limit is smaller than the lower limit? We'd have to write some logic to check for that. There's a much nicer way, and that's to use a range slider. So we'll see what that looks like once we put it together, but we'll call the first one xRange slider. Out of widgets, and if you're wondering like, how do I know all these names? Well, if we hit tab, we can see what kinds of stuff are in the widgets module. And the first thing, or what I'm going to put here is a float range slider. We can see it's listed right here, float range slider. And we can even start typing it, tab complete. If we look with shift tab at what's going on here, we get a short description, some parameters. This one's actually a little bit more generous listing the parameters than some of these. In some cases you kind of either have to guess what the parameters are or go look at the online documentation. In any case, for value here, we can probably see it's in here. It's supposed to be a tuple. Same thing with min and max. It's expecting tuples because you're getting like a range here. So we'll do a default of -5 to 5 for the value. For the min here, does that have to be a tuple? No, it's just a single float. Okay, so we'll make the minimum -10. We'll make the maximum +10. Make the step size equal to, I think 0.1 would be sensible. And let's set a description here, be something like xRange. All right, I want to make the same kind of structure for the y direction. It's going to be basically the same code, so I'm just going to copy and paste and rename that yRange slider and change the description to say yRange. Now let's preview what these things look like to see if we're happy with them. So I'll call display.display, and I'll show my xRange slider and my yRange slider. I am allowed to list more than one thing in the display function, so it can be, you can put all kinds of stuff in the display function. So I can have more than one widget, I can throw in text if I wanted, although usually you would just use print. In any case, how this is interpreted is it draws the first one, and then on the next line it draws the next one. So we can see our range sliders that have lower and upper limits that have the nice feature that you can't overlap the lower and upper limit. All right, next, what else did we want? We wanted a customizable color bar. So I think that would make sense as a dropdown. Let's call it CMap dropdown. So that's going to be a widgets dot, presumably dropdown. Let's see, D for dropdown, looks good. And let's see, what kind of stuff goes in here? A list of options and an index for the current selection, or a value for the current selection. I think if we just leave that argument off, it probably just picks the first thing. So we'll do options, and we'll type some of our favorite color maps in here. So I like seismic. Jet looks pretty cool. Like hot. And let's do bone because it sounds scary. We should give this a description. And we'll call that color map. And of course, we want to preview this. Oops, okay. Make sure I'm outside the parentheses. So here's our drop down. We can pick some different stuff. Okay, I think that should be what we need as far as widgets. Now let's make a function that the widgets will modify. Let's call it plot2d. And it's going to take f, which is going to be text. And so we're going to need to write some code that executes that text and does some Python calculations with it. We're going to need the x range and y range. And then we're going to need a color map. You'll notice these are not the same names as the widgets. These are the variables in the function, and I'm going to connect them to widgets. So it's legal to use the same names as the widgets, but it's a little bit more confusing. So I'm going to use slightly different names. Now in here, we need to, basically, we need to create some x values and y values. Let's do that first. So when you call a range slider, like we have up here in this cell, what you get is a tuple. So we can use tuple unpacking to extract xmin and xmax out of xrange. And we can do the same thing using yrange. Now let's make a mesh grid that's going to represent x values and y values. So we want to make some arrays here of our possible x values and y values. So let's call those steps. So we'll do x steps, and I guess x steps doesn't have to match y steps. We'll have to do this on individual lines. So we'll do x steps, and let's do a linspace of xmin to xmax to 100 steps. We'll do the same kind of thing for the y direction. I'm going to copy that. Y steps will go from ymin to ymax in 100 steps. And then I'll make a mesh grid using x steps and y steps. Okay, so that's my x values and y values. I need some kind of z values to plot. That's going to be where this f comes into play. So what I want to do here is I want to basically execute some code. You can see up here in our text box, we have some code that, as long as we're writing valid Python, we should be able to just execute that code. Python has two special functions that execute code. There's eval, which works for single line statements, and then there's exec for execute, which works for a longer code. We're going to do eval because we're going to have a single line statement. And we're going to just evaluate f. Now this is actually super dangerous code to write if you're sharing this with somebody else, because they could type in any kind of Python there and it would execute. And if that Python said, how about you just delete everything on the computer, your computer would then comply. In our case, it's fine because we are writing it for ourselves. So just be careful in general about writing that kind of code. Okay, so we'll evaluate the function, and then I think we're ready to show it. We will, of course, have to test our code and squash any bugs that may be there. So we'll show z. We want to make it look pretty, so we'll set the extent to the values that were provided. Xmin to xmax, ymin to ymax, so that we can see that the x and y axes are changing as we adjust those sliders. We also want to set the color map to cmap. So color map is going to be the name of our command. Here I was a little bit sloppy and I used the same variable name. Like I said before, that's legal, so I'll just leave it alone just so we can see that it is legal. Coming back to our code here, it'd be nice to show a color bar because that'll change as we change the color map, and we want to show our function. Okay, so that's our code to make our plot. Now let's connect everything to our widgets. And we haven't tested this yet, so there could be some bugs. We'll squash them as needed. So the first way we can connect this, I'm going to show you a few different ways. The first way is we can use interactive like we've been using. The function we'll call is plot2d. We're going to set f equal to ftext. So the argument f in our function needs to be matching ftext that the widget we made. Xrange is going to be set to the xrange slider. I bet you can guess what we'll do with yrange. And then cmap will be cmap drop down. And then let's show it. All right, moment of truth. Let's see what happens when I try to run it. Hey, it actually worked. Now let's see if it works the way I expect. So we drew all of our widgets, one after another, in the order we listed them here. And we've got our graph appearing down there. Let's try changing the x range. Okay, so we can see our graph changed when I changed the x range. Maybe I should have added some continuous updates false, but we'll just leave it be for the moment. Let's change the color map to seismic. We can see that changed. Hot, back where we were. Bone, it's sort of like a black and white. And let's try changing our function. So let's do x squared times 2x. I do have continuous update turned off for this, so I don't think it will do anything until I hit enter or click out of it. So there, where I hit enter, you see that the graph below changed for us. So we have a working set of widgets here. We've got some controls, and we have a graph that updates. Now this particular version, it just draws everything vertically, which is, it's okay, but you can see it's already getting a little weird. Like, we kind of have all this dead space off to the right. Wouldn't it be nicer to put the widgets over there? Well, so let's start looking at how we can control where everything gets drawn. So for the second version of our output, let's make some container widgets. We're going to start with some V boxes and H boxes, which are just these are just widgets that hold widgets. So I'm picturing in my head two side-by-side columns. So we're going to make column 1 be a V box, which stands for a vertical box. So this is one widget stacked on top of another, or multiple widgets stacked on top of another. And in there, I'm going to put my ftext and my cmap dropdown. So I'm picturing like I'm going to have the function entry box sitting on top of the color map. And I'm going to put that to the left of the two range sliders on top of each other. So a VBox is going to take a list of things you want stacked vertically. So the first thing I wanted was the function text, and then we'll do the dropdown. And so what I'm putting in here, these are the names of widgets. So it's widgets that go into this widget. So for column 2, it's also going to be a VBox, and this one's going to hold the range sliders. So we'll put an X range slider and Y range slider. And then I want to put those two things left and right. So I'm going to make, let's call this box layout would work. Box layout, and I'm going to use an H box, so it's a horizontal box. It'll be a list of widgets I want side by side. And what I want side by side are the two columns I just made. Okay, so we've got multiple layers here. We have the widgets themselves, like ftext and X-range slider, and I've put those inside of a container widget for these two VBoxes, and I've put those VBoxes inside an HBox. So let's look at what that looks like when we display it. Okay, so that's good. That's what I was picturing. So we've got the function text, we've got the color map, we've got the range sliders. And, you know, we can play around here, change this to jet, and you'll notice that actually these widgets are all still connected. They're all the same widget. They have the same name. They're referring to the same thing in the computer's memory. So you can have widgets in different places in your notebook connected to a function somewhere else. So anything I change here changes not just the image, but you can see change the color map up here. And if I up here change the color map to seismic, down below it also changes to seismic. They're all still connected. So normally if you were building a final project, you wouldn't do it this style where you keep having things displayed. You would build it all at once, or really you could build it anywhere, but you display it just once with a display call. Any case, so this is a nicer looking layout, although you'll notice this particular setup here didn't draw the image. It's not because I've already drawn the image. That's not a problem. I can draw this image multiple times. It's because I haven't told it to draw the image. All I've said here is make some widgets and put them in boxes. Okay, so we'll come to like, well, then how do I draw it? We'll solve that problem. But before we do that, let's look at yet another way we can lay this out. So this was just using a bunch of layout widgets. Another thing we could try here would be using some tabbed widgets. Those look pretty nice. So let me show you how that would differ. Let's call this one tab layout. And we'll do this as a widgets.tab. You can see there's tab, and if we look at the documentation, it says it puts them in accordion tabs. So we're going to have a list here of the stuff I want to put in tabs. Let's keep these columns, put them in different tabs. So I'll have column 1 and column 2. Then we're going to type the display code. Okay, so here we've got two different tabs, column 1 and column 2. So I like the tabs. I think that looks cool. What I don't like is how wide this is. This is super wide. It's as wide as my notebook, and there's no name in these tabs. These things are fixable. So the first issue here is it's super wide. We can control how wide it is by setting the layout argument. So layout here is going to be a dictionary of key values, and in that dictionary we're going to write code that's basically CSS, cascading style sheets. And no, you don't have to go off and learn how that works. I'm just showing you. This is mostly like for projects, you know, when you're working on group projects later. If you want something that looks really fancy, I'm just giving you some pointers of where to go. So in this case, I've got too much width. Let's make the width smaller by setting it to 400 pixels. And then in here we can do layout equals layout. There we go. So the name here, layout, could be anything at all, but the keyword argument is name layout. So that's got better spacing. I still don't have any names in there, but we can set those. We have to get to these through attributes though. We can't really set them in the original function call. So what we're going to do here is in the tab layout, I'm going to use, there's some set methods in here. It doesn't want to tab complete for me. But anyway, there are some methods in here called set title. And the way they work is they take two arguments, the index of which tab you're looking at, and then the text you want for the title. So the first one would be index 0, and we'll make its title something like function. because that controls what the function is going to be and what color map you want to use. Then we'll copy that code. And in the second tab, that would be index 1, we'll make it, that's like our ranges, we'll call those limits. Okay, so now we have some pretty looking output. And it's still connected, so we change the colors on here. It changes the original image, changes of the box layout approach we took. I'm not saying any of these are necessarily superior to the others. I'm just trying to show you some options. Let's come back to the issue that we're just not drawing the graph with these two. These are very nice looking, but they're useless if they don't actually draw the graph. And so what we have to do is we're basically going to put our graph in a widget, and then we can display that widget using boxes or tabs or some combination of those things. So the code we're going to use to make that work is not quite interactive, but instead it's called interactive output. So I'm going to call it out. This is going to be my output widget. So from widgets, I want to call not interact or interactive, but interactive output. See if it tells us what it does in here. So, I mean, it's telling us it's like, not, well, don't worry about interact. Well, I'll just tell you. So it takes our output, puts it in a widget. And so the way it works is it wants the name of a function, and then it, whatever that function prints or displays, it captures that and puts it in a widget. The second argument in here needs to be a dictionary of arguments to pass to it. This personally I think is super annoying. So I can't say like f equals or cmap equals in here. I have to use a slightly different syntax, which is I think actually kind of annoying. We need to have some kind of dictionary of arguments. Let's call it argdict, just to remind ourselves it's a dictionary. So in that dictionary, we need to have how everything connects. So that would be, we actually already wrote this code. If we come back up here, that's all this stuff. F equals F text, blah, 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 cmap equals cmap. Drop down, let's copy that. And let's put that in a dictionary. Okay, so with that, that's going to put our output into an output widget. And now we can display the output widget. That'll draw just the graph. Or it seems like it's the opposite problem. I'm only drawing the graph. Well, don't worry. Now that we have a name for this widget, we can put it in a container with anything else. So there's a couple ways we could do that. The very simplest way would be to use a single display statement to show a bunch of things. So we could show a tab layout, and we can show our output widget one after the other. So we've got our tabs up here, we've got our output down there, and then we can change the settings and see it appear down below. Or we can put our output widget in a box. So let's call this one Final GUI, because I'm almost done torturing you. Or maybe amazing you, I don't know. I'd say let me know in the comments, but don't really. Yell at me in class. Widgets.hbox, and we'll do in here. Normal hbox, so we're going to put in a list of what we want to see. So I'm going to do tab layout to the left and output widget to the right. Finally, if I display that, we get a nice final result here. So we've got our tab of widgets here to the left, our output to the right. We can make changes here. So we'll do like, just change what function we're drawing. Get this nice sort of circle showing up here. And of course, everywhere else in our notebook. But with combining these commands here, and this video I know took a while because I've shown you multiple ways to do it, but at the heart of this, what we did is we put widgets in other widgets. Basically, we used hbox, vbox, and there was a tab layout. But by putting widgets in other widgets, we can control where they're drawn. We can do this with the output using a special function, interactive output, which lets you capture the output and put it in a widget so you can draw it anywhere you want. And you put these pieces together and you can get a really nice interface to your Python code.